So in this question, we have an iron bar which is 0.7 meter long, and there are two edges of of knives, like at A and at B, and it is being kept uh, at these two edges, and these edges are 0.1 meter apart from the ends B at B point. This distance is 0.1 meter, and at a distance of 0.3 meter from, let's say, this end, we have a load which is hanging in a vertically downward direction. So 6 kilogram is its weight, and since it is acting under the action of the gravity of earth, so the force will be 6 times the acceleration due to gravity. And 4g, this 4 times g is the force that is acting on this rod because of its mass, and it is acting at its center of mass, which is 0.25 meter away from point A, or from the point where it is kept on the edge of a knife. So we are going to measuring all our distances from point A. So for that, we can say that this is 0 0, or since we are talking in one dimension only, so it is 0, and all the measurements are being done from this point. Now first thing, we can see that in the, let's say, if there are two directions, upward direction, downward direction, in that case there are two forces that are acting in the upward direction, which is Ra and Rb, where Ra and Rb are actually the reactions that we need to determine, and this 6g and 4g, this is the downward force. So we can say that R subscript A plus R subscript B is nothing but 10 times g. This is our first equation. Now what we do, since this whole system is kept at equilibrium, so for that, the net torque that is acting about A, that should be 0. Okay, so how we will determine this torque about A? So this is, okay, so 6, okay, so this is 0 equals to 6g, that is the force times the distance, and distance is 0.25 meter of, sorry, 0.2 meter of this 6g, 0.2 plus 4g times 0.25, and in the opposite direction, this will be acting the torque due to this reaction about this point A. So it will be Rb times 0.5, and we know that torque is nothing but distance times the force, and this distance is the distance which is being measured from the point about which we are trying to determine the torque. Now if we proceed, then it will be this will be negative direction because it's acting opposite to the other two. So it is 1.2 plus 1 times g equals to 0.5 R subscript B, and if we take g to be 10 meter per second squared, so this will be 22 is equals to 0.5 times Rb, and Rb is nothing but 22 divided by 0.5, and hence it is 44 Newton. So we have this, the reaction at edge B. Now at edge A, from equation 1, we can simply subtract this value, the value of R subscript B, from 10 times G, like means 100 minus 44 equals to 56 Newton. So this is the value of the normal reaction at the point A.